A die has 6 faces numbered 1 to 6. The die is biased so that when it is thrown, the probability of obtaining a 6 is 1/5. The die is thrown 5 times. Find the probability of obtaining at least 1 6 and exactly 3 6s. Okay, so that's the question then. Let's have a look at it here in summary form. So part 1 then, at least 1 6. So the probability of no 6s then is thrown 5 times. So the probability of obtaining a 6 is 1/5. So probability of no 6s on 5 successive occasions is 5/6 times itself 5 times, isn't it? So probability of at least 1 6 at least 1/6 is equal to 1 minus 5 over 6 to the power 6, which equals, and we can tap that in the calculator. A die has 6 faces numbered 1 to 6. The die is biased so that when it is thrown, the probability of obtaining a 6 is 1/5. The die is thrown 5 times. Find the probability of obtaining at least 1 6. Exactly 3 6s. Okay, so part 1 then, at least 1 6. Well, that would be 1 minus the probability of no 6s. Wouldn't it? That's what at least 1 6 would mean. So 1 minus the probability of no 6s then. Then we would have the probability of at least 1 6. Okay, probability of no 6s. The probability of obtaining a 6 is 1/5, so that would be 4/5 of not getting a 6. And then, but 5 times in a row, power 5. So we can tap that in the calculator then. 1 minus 0.8 power 5 equals 2101 over 3125. 2101 over 3125. And part 2. Okay, exactly 3 6s. Well, probability of exactly 3 6s then. For that to occur, you'd need to have 2 times when it wasn't a 6, so it's 4/5 squared. You'd need 3 times when it was a 6, of course. And how many ways can that happen when you've got 5 throws? Well, it'll be NC 5, choose 3. 5C3. Okay, 5C3. So let's tap that in the calculator then. 5C3 times 0.2 is 1/5 to the power 3 down to ground level times 0.8 squared. Oops, let's have a look at that then. Times, oh, I got 2 times there, equals 32 over 625.